Hey guys, this is going to be some notes for how we're going about 6.5, where we're going to be graphing two specific graphs. You know, if we think about y equals x squared, okay, that looks something like this. And if we talk about its inverse, it's going to be reflected on the line y equals x, which would give us a graph that looks something like this. Okay, so you can kind of see how it's been flipped along that axis, along that diagonal where y equals x. Now, in the case of an x squared, we end up with a problem here because we have the top half and the bottom half of this graph, and that's going to give us a non-function. So one of the first things we're going to do is we're going to acknowledge that we're only ever going to deal with either this part or this part. We're never going to do both at the same time. So what this really comes down to, if you think about solving for switching x and y and solving for the inverse, you'd get x equals y squared, and to solve for y you'd have to take a square root. That square root would have a plus or minus in front of it. We're either going to pick the positive or we're going to pick the negative, never both, because that creates a non-function. So in these square root graphs that we're going to be graphing today, they're going to look a lot like this. Okay, there will be a number out front, and then a square root of x minus h, and then outside of it plus k. Now this point hk, the same thing we've been doing the whole time, is essentially the vertex of the parabola that's been turned on its side. So when we think about an equation like y equals negative root x plus 3, and then maybe plus 2, we first want to acknowledge that the vertex, or the key point here, will be at the opposite of what's with x. That'd be negative 3. And then this number, whatever's added or subtracted, just the way that it is. So negative 3, 2 becomes the ordered pair where our tip, or our vertex of the parabola is. Now remember, it's on its side, so I'm going to go to negative 3, positive 2, put a dot. Then if I use an xy table, I should be able to get more information. Because this is negative, I expect it to trend downward. And you can imagine that being half of the parabola going down as it goes to the right. Because of the fact that this is coming from a square root graph, and this point right here is a beginning of the graph. It's not just one point. It is the point from which the graph flows. That's going to affect what we call the domain and range. Remember that the domain is a list of all the possible x values we can use in this equation. If you look at the graph, x seems to start here at negative 3 and go to the right. That would tell me that x is greater than or equal to negative 3. That's this value here. Now this is important. If we used a number more negative than negative 3, say negative 4, if I used that in for my x, I'd have negative 4 plus 3, which is negative 1. And I would have to take the square root of that, giving me an imaginary number. Imaginary numbers are not going to be part of a graph. And so these numbers have to be rejected and never used when we talk about graphing the square root graph. Coincidentally, we can see that it's starting here at a height of 2. So the range, which is all of my y values, would be that y, it's either above or below that value. Well, it seems like all of my graph exists going downward, which would tell me that I'm below or equal to 2. We're going to need at least 3 points, right? We're going to need some data here to graph in order to be confident that we're getting the actual curve drawn correctly. And that can be done from your table in your coordinate, or from your XY table in your graphing calculator. If we talk about the other version that we're going to talk about today, y equals x cubed. Now y equals x cubed typically is going to look like this. And when we reflected on that same coordinate, we would end up with that same xy line. We'd end up with a graph that goes sideways, sort of an S shape, or if we make it negative, a Z shape. So when we talk about a cube root graph, it would also have an A, and then a cube root of x minus h, and then outside b plus k. Now this hk is not going to be a vertex per se, but it will become the center or pivot point in the graph. And so if I had y equals 2 cube root of x minus 3 minus 2, the point 3, negative 2 would be 1, 2, 3, down 2, would be the point in the center from which around everything else moves. Knowing what I know about this graph, I know that it's going to be here and here. 3 points, these first 3 points are going to seem like they're in a straight line. I'm going to need more information out further in order to cause the curvature to happen. If we go out far enough, there'd be another dot there and another dot there, creating this sort of S-type curve as I go from left to right. And that's our curve. Now when we go to do the domain and range for a graph like this, the domain would be a list of all the possible x's. Well shoot, this thing goes forever to the right and forever to the left. There are no restrictions. So I use this fancy looking R. It's a double-lined R. There should be more. Oh goodness, Mr. Welch, you're a mess. Double-lined R. Looks like a paragraph symbol, sort of. We have the double line and then the P. This will be just with an R. That stands for all real numbers. Feel free to write all real numbers. The range, though, let's think about that. Does this graph continue to go upward forever? And this graph continue to go downward forever? The answer is yes. So it would also be all real numbers. You guys are going to have some questions. Look at the homework video for some examples of specific problems. But this is what we're after, these two types of graphs. Remember, the square root graph will either go up like this or it'll go down like this, one of the two. And it will definitely have to have that starting point. A cube root graph will either look like this, that S shape, or if it's negative, it'll look like more of a Z shape. Sorry, that should be a little flatter there. But at any rate, hopefully that's enough to help you and get you what you need, and we'll see you in class.